In the winter of 1909, in a shipyard on the Kennebec River in Bath, Maine, workers stood beneath a wooden hull that rose higher than a 5-story building and stretched longer than a city block. No engine had cut a single plank of it. No power saw, no electric drill, no hydraulic crane had touched the timber. The ship was called the Wyoming, 6 masts, over 400 feet from bow to the tip of her bowsprit, built entirely with hand tools by men who measured lumber in board feet and trusted their own eyes more than any blueprint. She would become the largest wooden sailing vessel ever built in America, and almost nobody outside the shipbuilding towns of Maine remembers how she was made. Before steel hulls took over the merchant trade, wooden ships were still being built at a scale that strains belief today, and they were built the same way ships had been built for 300 years, by hand, with an axe, an auger, and a crew that knew wood the way a blacksmith knows iron. If you like seeing how things were really built, hit subscribe. There's a lot more of this coming. To understand why anyone would build a wooden ship that size, you have to understand what the coastal trade needed at the turn of the century. Coal had to move from Virginia to New England. Lumber had to move from the Gulf states to the cities. Steamships were faster, but they burned fuel and required engine crews and machine shops to keep them running. A big schooner under sail cost far less to operate. It carried enormous cargo, needed a small crew, and once the wind filled the sails, it moved for free. So the shipyards of Maine kept building wooden schooners bigger and bigger, chasing the economics of scale the same way railroads chased longer trains. The Wyoming was the end point of that chase. 6 masts, a crew of only about 14 men, and a cargo hold that could carry roughly 6,000 tons of coal in a single voyage. The men who built her were shipwrights, and shipwright was not a job you learned in a season. A boy apprenticed at 14 or 15, sweeping shavings and hauling timber, and by the time he was cutting his own joints, he had spent years watching men twice his age read the grain of a log before it was ever squared. Alongside the shipwrights worked caulkers, who drove oakum into the seams between planks with mallets shaped for exactly that motion and nothing else. There were joiners, who built the cabins and finished interior work. There were riggers, who climbed bare masts with nothing but a bosun's chair and rope to string thousands of feet of standing and running rigging by hand. A yard the size of Percy and Small, where the Wyoming was built, might employ several hundred men across all these trades at the height of a build, and every one of them worked outdoors on the ways, through Maine winters that froze the river solid, and summers thick with black flies off the water. Before a single log was cut to shape, the ship existed only as a half-hull model, a small carved wooden block showing one side of the vessel sliced down the centerline, which the master builder shaped by eye and years of accumulated judgment, rather than from a formal set of engineering drawings. That half model was then measured, section by section, and the measurements were scaled up and transferred to the mold loft floor, a long open room with a smooth wooden floor large enough to draw the entire ship at full size in chalk. Loftsmen crawled across that floor for days, snapping chalk lines and bending thin wooden battens into fair curves to define the exact shape of every frame in the hull. From those full-size chalk drawings, workers built thin wooden molds, patterns that were carried out to the timber yard and laid directly onto rough logs so the hewers knew precisely where to cut. There was no margin for a mistake made at this stage, because an error in the mold loft became a permanent error baked into the shape of the finished hull. The timber itself came from a long way off by the time the big schooners were being built, because New England's own oak forests had already been thinned by 2 centuries of shipbuilding. Southern yellow pine came up from Georgia and the Carolinas by rail and by barge. White oak for the frames came from wherever agents could still find stands large enough to yield the curved timbers a hull required. A ship's frame is not built from straight lumber bent into shape. It is built wherever possible from timber that already grew with the curve the shipwright needed, because a naturally curved piece of oak is stronger along the grain than a straight piece forced into a bend. Finding those pieces meant walking forests and marking specific trees months or years before they were needed, a trade of its own called ship timber hewing. Once the timber reached the yard, the work began with the keel, a spine of squared timber laid down the center of the building ways and often built up from several long pieces scarfed together, since no single tree could supply a keel 300 feet long. From the keel rose the frames, the ribs of the ship, each one assembled from multiple curved timber sections bolted together into a single rib shape, then hoisted upright and fastened to the keel with iron drift bolts driven by sledgehammer through holes bored with hand augers, sometimes 3 feet long. A large ship might require well over 100 of these frames, each one weighing tons, each one raised into position with block and tackle and the muscle of a dozen men hauling on a line, no engine involved anywhere in the lift. Planking came next, and this is where the Broadaxe and the adze did their real work. A Broadaxe, flat on one face and wide in the blade, could hew a rough log into a squared timber faster than most people today would believe possible, guided entirely by a chalk line and the hewer's own steady hand. The adze, a curved blade on a short handle swung down between the feet, was used to smooth and shape planking to an exact fit, a tool dangerous enough that a careless swing could take off toes, and skilled enough in the right hands to fare a plank to a curve within a fraction of an inch. Planks were steamed in long wooden steam boxes heated by boilers until the wood went soft and pliable, then rushed to the hull while still hot and bent around the frames by hand, clamped in place and fastened before they cooled and stiffened again. Timing mattered enormously. A plank that cooled before it was fully clamped would crack or spring back, and the whole steaming process had to run again. Fastening was done with iron bolts in the largest structural points, and with treenails everywhere else, wooden pegs of locust or oak driven into bored holes to lock plank to frame. A treenail swelled slightly with moisture over time and gripped tighter rather than working loose the way an iron fastener could rust and fail. Shipwrights drove these by the thousands into a single hull, each hole bored by hand auger, each peg driven home with a mallet and trimmed flush with a chisel. The math of it is staggering to say out loud. A ship the size of the Wyoming required something on the order of 1 million board feet of timber, assembled by crews using nothing more mechanically advanced than steam heat, block and tackle, and the strength of their own arms. Caulking held the whole hull watertight, and it was its own specialized craft entirely. Caulkers worked their way along every seam between planks, driving strands of oakum, loosely twisted hemp fiber soaked in tar, into the gap with a caulking iron struck by a wooden mallet in a steady rhythmic beat that yard workers could hear across the whole waterfront. Too little oakum and the seam leaked. Too much, driven too hard, and the caulker could actually spring the plank itself, opening a worse gap than the one he started with. After caulking came a seam of hot pitch poured directly over the packed oakum to seal it against the water permanently. A big hull might take caulkers weeks of steady work to finish, moving inch by inch along seams that ran the entire length and breadth of the vessel. The masts were their own separate feat of engineering entirely. On a six-masted schooner like the Wyoming, each mast stood well over 100 feet tall and was itself often built up from more than one piece of timber banded together, since a single tree tall and straight enough to serve as a full mast in one piece had grown scarce by the early 1900s. Raising a mast of that size meant building a temporary set of shear legs, angled timber supports lashed together at the top, and using block and tackle purchases with enough mechanical advantage that a relatively small crew could inch a mast weighing many tons up off the ground and into a vertical position before lowering its heel into the step built for it deep in the ship's hull. A misjudged lift, a frayed line, or sheer legs set on unstable ground could bring the whole rig down, and yard workers treated mast raising as one of the most dangerous days of any build. Above the frames and planking, carpenters still had a deck to build, laying heavy deck planks over transverse beams that were themselves braced by curved wooden knees bolted into the hull sides, a joint that had to carry the working strain of loaded cargo and heavy seas without splitting. Hatches, deckhouses, and the steering gear all followed, each one built to fit a hull that was never perfectly symmetrical, no matter how carefully the loft drawings had been made. which meant carpenters spent long hours scribing and fitting each piece individually, rather than working from identical parts. Once the hull and deck were essentially complete, riggers took over, running miles of rope and wire through blocks fixed at the mastheads, all of it rove by hand from staging and rope ladders, with the ship still sitting on dry ways, since a schooner, rigged with 6 masts, needed her running rigging tuned and tested before she ever touched open water. The risks in this work were constant and rarely written down in detail. Men fell from staging built along the hull sides, sometimes 40 or 50 feet up, with nothing beneath them but the ways and the mud of low tide. Augers and adzes took fingers when a hand slipped or a plank shifted under the blade. Steam boxes scolded men who worked too close when a fitting failed. Falling timber, a beam swinging on a line, or a frame not yet fully braced could crush a man in an instant. And shipyard towns understood this as simply the ordinary cost of the trade, the same way mining towns understood cave-ins, or railroad towns understood men lost coupling cars. Wages were modest and the hours were long, sunrise to sunset for most of the year, extended further when a launch date had been promised to the owners who financed the ship. Even the launch itself carried real danger. A hull of that size, resting on a cradle of timber ways greased with tallow and soap, held an enormous amount of stored energy the moment the last blocks were knocked free. Yard workers timed launches to the tide, since a hull that stuck partway down the ways, or slid crooked, could tear itself apart or crush the men working the restraining lines. A successful launch looked simple from the crowd's side of the fence, a ship sliding smoothly into the river to cheers, but it was the product of weeks of preparation, checking the angle of the ways, the grease, and the tide tables, done by men who understood that thousands of tons of moving timber does not forgive a miscalculation. If you have made it this far, you already understand why this trade nearly disappeared, and understanding that is worth sticking around for. Subscribe if you want the rest of these stories, because there are a lot more ships, bridges, and impossible builds where this one came from. The Wyoming herself was launched in December of 1909, sliding down the greased ways into the Kennebec River in front of a crowd that understood they were watching something close to the outer limit of what wood and hand tools could achieve. She sailed for more than a decade carrying coal and lumber along the Atlantic coast, a working vessel rather than a monument, until she was lost with her entire crew in a storm off the Massachusetts coast in 1924, one of the quiet tragedies that followed this trade, for as long as men built ships from wood and sent them out onto open water. Steel had already begun replacing wood in shipbuilding well before the Wyoming was launched, and within another decade or two, the great wooden schooners were effectively finished as a commercial trade. Steel hulls could be built larger, repaired faster, and did not require the specific stands of curved oak that had grown harder and harder to source every year. The shipwrights, caulkers, and riggers, who had spent their whole working lives in wooden hull construction, either moved into steel yards to learn an entirely new trade, or aged out of the industry as the last wooden ways went quiet along the Maine coast. A handful of small yards kept building wooden fishing boats and workboats on a much smaller scale, and that thread of hand-built wooden construction survives today only in a small number of traditional boat-building shops and museum restoration projects, where a few remaining craftsmen still steam plank by hand and still know how to read a curved timber for the frame it was meant to become. What is left of the great age of wooden shipbuilding is mostly gone from the water itself, but the knowledge did not vanish completely. Maritime museums along the New England coast still maintain preserved vessels and detailed archives from yards like Percy and Small, and a visitor can walk through the same buildings in Bath where these hulls were framed and planked by hand. The tools still exist in museum collections, the broadaxes and adzes and caulking irons, heavy and worn smooth by hands that used them every working day for decades. What those men built without a single power tool still sets the outer edge of what wooden construction can achieve, a boundary nobody has needed to push past since, because nobody builds ships out of solid timber at that scale anymore. They built the biggest wooden ships in American history with an axe, a mallet, and a crew that trusted its hands over any machine, and for a few decades on the coast of Maine, that was enough to move 6,000 tons of coal under sail alone. Thanks for watching. If you want to see more of how America was actually built, subscribe, and I will see you in the next one.